Go.
Okay, so this video is to help determine the Gibbs free energy, which basically determines like the feasibility of a reaction. So first off, this is the equation: delta G equals delta H, which is the enthalpy minus the temperature times the entropy. So first of all, we need to find out the enthalpy. So to do that, we need to use two equations. Well, sometimes they will give you the enthalpy in the question, but for this example, I'll show you how to find out what it is. So the first equation is delta H equals plus or minus the heat over the moles, and this is of the surroundings. But first, to do this, we need to find out what heat is, and to find out what heat is, we need to use the equation heat equals mc delta T, and that is where C is the specific heat capacity of whatever it is, like the surroundings. So this here would be, and M is the mass of the surroundings, so we've got 100 centimetre cubed of water there, so that would be 100 times the specific heat capacity of water in this case, which is 4.18. And then the change in temperature, which is 20 degrees to 65, so that's 45 degrees. 45. And then that equals, that equals 18,810 joules. And it's when, for this equation, both of these need to be in the same units, so we change it into kilojoules, and do that, you divide by 1,000, so that will equal 18.81 kilojoules. And then if we go back up to this equation here, so we can find out delta H, the plus or minus bit basically is like the opposite of this, because this is for like the surroundings and this is for the chemicals. So if like you've lost, so if this is like gained the, so if it gains it, then the surroundings gains it, then the chemicals will have to have lost it. So if we've got a plus here, we need to have a minus up here. So in this case, we're going to have, because it's plus, we're going to go minus 18.81, and moles were 0.2, and then that equals 94.05 delta H. So now we have delta H as from our equation. Now we need to move on to find out what the temperature is. So the temperature always has to be given in Kelvin. So as it says here, you need the initial temperature, which is 20 degrees. So T equals 20 degrees. But as we have to get it in Kelvin, what we have to do is add 273 to whatever number you have in degrees to make it in Kelvin. So in Kelvin, the temperature equals 20 plus 273, which equals 293 degrees Kelvin. So then that is the T part of our equation. So now we need to move on to the delta S. To find out what delta S is, that equation is the sum of the like the entropy of the products minus the sum of the entropy of the reactions. So if we're going to use these numbers here, that will give us products is 214, then we have to take away 82 plus 44 as our reactants, and that gives us 88, and that is joules. And then we need to make that into kilojoules, so we need to divide that by 1,000, which equals 0.0 can sub in the values. So now we have delta H as minus 94.05, minus T, which is 293 times 0.088. So that gives you, minus 94.05 minus 25.784. And then that equals minus 119.834. And that is in kilojoules. But you don't really need to use the units in this, because basically as whatever you get as your delta G, if it's a minus, then that means that the reaction will definitely categorically happen at that temperature. And if it's a positive, then it won't ever happen at all. But and also technically, it will just about happen when it's 0. So if you wanted to, if there was a question saying like, what would the minimum temperature be required for it to work, or the reaction to happen, you'd have to sub in delta G as 0. So as a quick example, if you had delta G as 0 in this equation, when you rearrange it, it would give you, I'll show you a quick rearranging. To make it T is delta H over delta S. And then that equation you can use to find out what the minimum temperature would be for the reaction to happen, and that would be in Kelvin. So if you wanted to change it into degrees, you just have to minus 273 again in 2 degrees C. So yeah, that kind of concludes everything. So first of all, you just need to work through it step by step. So using these two equations to find out delta H, and then remember to put it into Kelvin when you do the temperature, and make sure that when you find out the delta S, you need to make sure that that and the delta H are both in the same units, kilojoules, and then you just put it in there, and then it's all gravy. So yeah, thanks for watching.